According to legend, the city behind me was founded by an orphan suckled by a she-wolf. He took his plough and marked out the limits of the settlement that would bear his name. His name was Romulus, and the city, needless to say, was Rome. In the centuries that followed, the Romans would spread their knowledge, their technology, their way of life across the known world. It was the greatest and most enduring empire the world has ever seen, and some 2,000 years later, it is a know-how that continues to astonish us. In 753 BC, Rome arose from the marshes of the Tiber River. As an eternal student of history, I'm awed by what the Romans accomplished using the most basic technology. Colossal doesn't even come close. Monumental buildings, paved streets and apartment buildings, a water distribution and sewer system that kept 1 million people healthy. Yet Roman technology built more than this city. As the empire grew, that technology spread, shaping the ancient world and reverberating into ours. To understand the role that technology played in building the Roman Empire, I had to go far beyond the capital, out to the frontier. Rome was the heart of an empire stretching from Scotland to Syria. Roman legions occupied 1/4 of the world that would become 36 modern nations. From these German forests on the northern frontier to the Indian Ocean, military might shaped the new world in the image of Rome. Here in Germany, that history is alive. Across the country, experimental archaeologists, like these modern-day Romans, search for clues to the Roman success, down to the smallest detail. Reminders of the Roman occupation are scattered along the frontier. They reflect far more than military conquest. 2,000 years ago, the Romans built a wall here, and this modern reconstruction can give you a sense of the power of the Roman way. It was not just a physical barrier, it was, as much as anything, the edge of an idea. When Roman soldiers stood sentry here, they looked out over a land of uncultured bogs and forest. Behind them, on the other hand, was the Roman world. The legions marched for the glory of Rome and all that it meant. Towns and cities, roads and baths. Organised and well-trained, legionnaires carved the ways of Rome into the colonies, crushing all who opposed them. Roman military success relied heavily on the technology of others. After centuries of warfare, the Romans knew what worked. Much of their military equipment was based on designs adapted from their enemies. Their sword, or gladius, was originally Spanish. Their shields were Samnite. Their armour was derived from a Celtic design. The helmet was Etruscan. With one exception. The pilum was a Roman original. What made it so special was the tip. Shaped like a harpoon, it was designed to penetrate, impossible to pull out. An innovative design, but first, you have to hit the target.
Want to try?
Yes, thank you.
Like this, straight on the target.
Straight on the target. Okay, we'll see how I go. It's heavy, huh? It's tougher than it looks. Now, in slightly more expert hands, this was an absolutely deadly weapon, and this shows you why. If it's thrown properly, a pilum will go straight through a shield and through the armour of the poor fellow behind it. Even if it doesn't, it was very effective, because as you can see here, it lodges in the shield. Now, a shield with a great big pilum hanging off it may as well be no shield at all. Roman soldiers were well trained in close combat to follow up the pilum attack.
Und los jetzt! Jo!
But adaptability gave the legions another battlefield advantage. Take the Scorpio. Originally a Greek invention, Roman innovations made it a highly effective weapon. Tightly wound rope, used here, stores the energy. The Romans used horsehair, or, according to legend, even human hair, for more power. Featuring a refined ratchet mechanism to control string tension and calibrated elevation, the Roman version was extremely accurate. Organised into crews, Roman soldiers could deliver death more effectively than the barbarian hordes they faced. Using these adopted technologies, combined with iron discipline and a systematic approach, the Roman legions advanced the borderlines of the empire. The Romans excelled at drawing lines. The line was at once the symbol and an instrument of their empire. These latter-day Romans behind me are enthusiasts who attempt to recreate the lifestyle of the 32nd volunteer cohort. And the reason why they're here is that this is the Salzburg, formerly a fort on the edge of the Roman world. Here was one of the most important lines the Romans ever made. The Romans used rivers and coastlines to mark the line between their world and the unconquered. But in central Germany, the local tribes fiercely resisted Roman rule. So the Romans built a border that cut across 350 miles of forests and hills, a truly remarkable piece of ancient engineering. This would be tougher in a suit of armour. However, I have just climbed one of Europe's most astonishing historical monuments. This is the Limes, the boundary wall that marked the edge of the Roman Empire. And while today it might look like a large mound of earth, it is in fact one of the most astonishing monuments of the Romans' engineering and building skill. There's one stretch of the wall which runs for 65 miles, with a deviation of only about 30 inches. You or I find it tough enough to cut a roll of Christmas wrapper and keep it straight, but the Romans could build an entire wall for many, many miles and keep it as straight as an arrow. The question is, how did they do it? Roman surveyors used an instrument borrowed from the Greeks, the groma. A rotating arm supported a wooden cross. From its 4 tips hung 2 pairs of plumb bobs. The surveyor sighted across one pair to project a straight line. Assistants placed markers. Sighting across the other set out a right angle, which the Romans used to plan their cities. This was an inspired application of a basic principle. For while the tools may have changed, the concept of sighting along several points to create a straight line is still the basic idea behind modern surveying. Once the line was laid out, special detachments of engineers began building the limes. Constantly on the alert for barbarians, they would clear the forest and build fortifications. Every 800 yards they constructed a tower like this one for quick communication in the event of an attack. Eventually there were more than 1,000. In areas where rivers didn't create natural borders, the engineers built palisades to mark the limes that sent a clear message: private property, no trespassing. And to drive home the point, they built forts every 4 miles, 200 in all, like the Salzburg, here in the Taunus Mountains near Frankfurt, Germany. Roman surveyors looked for the most direct route between 2 points. Following that rule, they built some of the fastest connections in ancient history. The Romans built a vast network of roads. Many were very solid. Stretching from the farthest frontiers back to Rome, roads were the veins and arteries that fed the heart of the growing empire. A close look at a section of one of their most legendary construction techniques, and you appreciate the challenge. Roman engineers had to be both creative and skilled. When the Roman engineers built a road, they built it to last. This is the Via Appia, the oldest and most famous of all Roman roads. It runs from the heart of Rome itself all the way down the Italian peninsula, a distance of more than 400 miles. Now, the Roman engineer used local stones, and he used the shape of the stone itself. He'd fit them together as craftily and as cunningly as a jigsaw puzzle. The tighter the fit, the more the water would run off, the longer the road would last. Road construction was based on a compact earth footing, with retaining walls and a ditch on each side. A small layer of stones in mortar was placed on top, followed by a layer of hard filling, probably gravel, and finally finished with a slab surface. Now, just how much traffic this road carried, you can see here from these grooves, which were dug into the stone by the thousands of wagons that passed along this way over the course of many centuries. This was one of the arteries of empire. It carried goods, ideas, and, not least, armies. Building as they advanced, the Roman legions forged the links that held the empire together. The greatest structures of Rome were replicated wherever the Roman way prevailed. Here in Rome, it's easy to see why and how. Their success rested on another adopted technology, the arch and its derivative, the vault. Without them, one of the greatest buildings would have been impossible to construct. The size of a modern football stadium, the Colosseum walls reach 4 stories high. If they'd been solid, the walls would have collapsed under the weight of the enormous number of bricks it took to build them. By using the arch, Roman builders borrowed a Greek invention to distribute the weight. Here's why the arch is so effective. From where the arch begins at the so-called springers, wedge-shaped stones called voussoirs are held in place by a central stone called the keystone. From here the weight is evenly directed down to the piers. Without the arch, there was no possibility of building a building as big as this one. It would have collapsed under its own mass. It is scarcely an exaggeration to claim that without the arch, there could have been no Rome. And if you step outside the city, you can see just how important the arch was to the Roman way of life. The Aqua Claudia is one of 9 aqueducts that together delivered 46 million gallons of water to the ancient city every day. Thanks to the arch, the Romans were able to create a vast water system. Here at Rome's Porta Maggiore, 4 aqueducts intersected before connecting to a labyrinth of lead pipes that distributed water throughout the city. This is where the aqueduct ended. But in Roman times there were similar fountains throughout the city, and that there were so many was because they were absolutely vital to the functioning of the city. Only the very rich could afford water in their own homes, so for Joe Public, or if you like, for Julius Public, this is where you got your water. And that's not all. Rome is and always was a sweltering place, and this functions much like a giant outdoor air conditioner. The fountains shoot water into the air. The wind carries the spray and the spray cools the air. It's a pretty refreshing side effect. More than that, they were vital to the maintenance of public health. Groundwater was a continual health risk, and the water from the Tiber was absolutely filthy. So this fountain, and the many others like it, kept the population healthy. As the legions expanded the empire, they followed a basic principle. Public health relied on clean water brought in by aqueducts supported by the arch. The Roman engineers' long association with the arch was more than just a marriage of convenience. It was a love affair. For while a structure such as this one served an eminently practical function, bringing fresh water to the city, it did something more than that. According to the historian Tacitus, Rome's grand public works advertised Roman might. And nowhere was this more true than in the colonies. This scene behind me begins with the Romans. The river is the Rhine and the city is Cologne, its name a derivation of the Latin colonia, meaning city, the city that was founded here by order of the emperor. After colonization, city building was the next job for the legions, because Roman soldiers were more than warriors. Most had learned a trade before joining the legions. Across the empire, the soldiers were the engineers and builders. After 2,000 years of building and rebuilding, only subtle reminders of its Roman history remain in Cologne. Like today, there were sidewalks, piazzas and fountains that made the city a home away from Rome for the colonists. Eventually, 50,000 would call Cologne their home. The key was water, but not any water. To get to the quality and quantity they required, they built the second longest aqueduct in Roman history. It can still be seen if you know where to look. To span this valley with bridges like this one was far too expensive. They came up with an ingenious solution. This thing is an absolute marvel. Normally, when we think of a Roman aqueduct, we think of the vast bridges and spans that they put up across rivers and valleys. But in fact, it was much more humble structures, such as this one, which really did the heavy lifting. To build this aqueduct, they'd dig a trench along the side of the hill, following the contour but sloping slightly down. They'd face the trench with bricks and mortar, put up an arch, and then bury the whole lot under the earth. It all functioned like a giant fridge. The water that flowed through here was kept beautifully cool. So any citizen in Cologne was always guaranteed a glass of water that was cool, fresh and clean. Before water quality tests were invented, the Romans tasted and smelled the water. They looked for its effects on the people, whether their hair was healthy and likewise their skin and teeth. And if they'd grown old, the water passed the test. Only then would the engineers lead the water into the city. A city like this received hundreds of millions of litres of water through its aqueducts, and they had no tap, no faucet with which they could turn it off. So the water had to go somewhere, and this was the Roman solution. If we're going to understand how the city up above worked, we have to start here, down below. This is Roman plumbing, but it's much more than just plumbing. It's absolutely astonishing. We'd call it a stormwater drain, but to the Romans it was far, far more than that, because these drains run for hundreds of metres under the city, straight as an arrow, dropping a few centimetres every few hundred metres. It was a system of astonishing efficiency, and it was this that stopped the city from flooding and from choking on its filth. The Romans established a high standard of public health across the empire. The Roman world continued to expand. As the legions pushed the border further north following the Rhine, they established the northernmost frontier city at Xanten. At the archaeological park that's here today, research scientists and fans of Roman history are keeping the legacy alive. Part of their research is dedicated to understanding just what made the Romans so successful. In an effort to learn as much as possible about Roman technology, they conduct some fascinating experiments. Like reconstructing this model of a Roman catapult called a ballista. Assembling this war machine is something they only do once every few years. We were lucky to be here, even though no one was certain whether or not it would shoot. But one thing became quickly apparent. The Romans had a lot of muscle. Our guys needed a forklift. This is the weapon of mass destruction of the ancient world. It's an exact reconstruction of a Roman ballista or catapult. And like so much Roman technology, the invention is Greek. The perfection of that technology is Roman. Essentially, the principles and materials are relatively simple. The principle is one of tension, and the tension is stored in these ropes, in this case hemp, but we know the Romans used sinew, which are wound tight and maintained in a state of constant tension by this brass drum and steel bar. This is the sling that fired the projectile. It's made of sinews, like these ropes here, that keep the tension stored in the machine. It is, if you like, a colossal bowstring which was wound up and then released. Just how much force it maintained can be sensed from this arm, which apparently was one of the wearing parts of the machine. It would regularly give way and shatter like this. So it was a dangerous machine for the crew, but far more dangerous for the people in the firing line. our modern-day Romans came prepared, complete with helmets and armour, and even the Latin commands.
Ballistari ad ballistam!
What we're going to do now is we're going to fire a Roman catapult.
Ansas aperite!
Now they're winding up the tension. They've got a hell of a lot of force in this thing. They're creating a huge amount of pressure by cranking it up at the back here.
Intendite!
This sled is coming back, and these are the levers that pull it back. Every time they're increasing the tension, and they can calculate more or less exactly how much force there is in this by counting the number of ratchets. So each click means another few yards and a few more dead barbarians. It's very, very tight. This thing is going to go off like, whew! Give it one more. Now we put the ball in. It's just a simple leather sling. Now we're going to fire it.
Et jactum!
Let's go. That is absolutely unbelievable. If you were taking on the Romans, you've effectively seen the equivalent of the ancient B-52.
Intendite! Et jactum!
This is the Roman version of a cannonball. It weighs about 8 pounds, and this machine could hurl this ball a distance of about 1/4 of a mile. No European army would have anything as destructive as this until the age of cannons and gunpowder. But believe it or not, this is a relatively small example. We know that when the Romans took Jerusalem, they fired balls weighing up to 30 pounds into the city. But part of what made it so effective, so deadly as a weapon, was its psychological impact. When this thing landed, being made of light limestone, it would shatter, sending a cloud of shrapnel into the defenders of the city. It was a weapon of shock and awe. Shielded by a city wall and guarded by a legion, the military founders made sure their new home was a reflection of Rome. I walked across the park to a place where Rome's influence on the city planners clearly left its mark. The building behind me may look like an enormous greenhouse, but it is in fact an exact replica built on a 1-to-1 scale of the outline of a Roman bath. The ruins of that bath lie beneath. Public bathing was at the heart of the Roman lifestyle, and this bath out here in the colonies is designed just like the great baths in Rome. Bathing consisted of a specific routine performed in various temperature zones, ranging from cold to a very hot 120 degrees Fahrenheit. It was all done with an innovative heating system called a hypocaust. I met with Dr. Norbert Zieling, Director of Excavation at the Xanten Park, to learn more about the Roman heating system. What are you going to show me?
I want to show you our bath. This room is one complete hypocaust in Roman times, of course. And what you see here is just a reconstruction of it.
So this is just part of the original hypocaustum that originally would have been in the whole room, is that right?
Yeah, that's right.
Does this rate as a large one or is it a small one?
It's a large one.
This is a big one. And is this pattern of construction typical of a hypocaust?
Yeah, it's quite typical. You can find it everywhere in the Roman world.
And this is how the Roman heating system worked. In a hypocaust, literally translated the fire beneath, air was heated in a wood or coal-burning furnace and directed under a floor raised on small pillars. Clay pipes were built into one or more walls, and as the warm air rose, both the floor and the walls heated up.
It took a lot of time to make it hot, but when it was hot,
It stayed hot.
it stayed hot.
So in effect what you're saying is that this was a very thermally efficient system.
It was, yeah, that's right.
Regardless of where they went, bathing was a crucial component of the Roman way of life. But I wanted to find out for myself just how well the Hippocrates system worked. Visiting the archaeological park in Xanten was like stepping back into Roman times. But when it comes to understanding history, nothing beats first-hand experience. Xanten offered a rare opportunity thanks to a reconstructed private bath. I was curious to find out what made the Roman bath so special. And when the management offered to heat up the Xanten bath, the park's architect, Dr. Peter Kienzler, was only too happy to join me.
These are the changing rooms.
This is where we take off our togas.
Yes, of course, that's what we have to do here.
So the Romans bathed completely in the nude.
Yes, exactly, and we do it the same way, not in Rome, but also here in Xanten.
And we're going to do as the Romans did.
Yes, wherever the Romans went to, they brought their culture with them, and bathing is very much a part of the Roman culture.
It was more than just a place to wash up. Romans went to the bath to relax and socialize. Bathing was at the heart of Roman city life. This was going to be a treat. I had a feeling Peter's Roman bath clogs would come in handy, given the hot floor. Entering the hot room, I was surprised how much heat the Hippocrates could generate. Peter pointed out an essential component.
The Romans invented double pane glazing, so they had an outer pane and an inner pane, and keep the heat in the room.
And this would serve to keep the room warm all through the year?
Yes, exactly, so you could even have a bath in winter time. Everything was in here very nice and warm.
Can we give it a try?
Yes, let's try it.
This is a delightfully warm bath, Peter. Is it heated by the same system that heated the floor and the walls?
Yes, there's a testudo over there.
Testudo means turtle.
Exactly.
The amazing thing about the Hippocrates is that while it heats the floor and the walls, it also heats the bath water. A hollow receptacle called testudo sits directly over the fire in the furnace. It opens into the bath, and by way of convection, the cold water sinks and the hot water rises. The cold water circulates into the furnace where it is heated, and then flows back into the bath. A clever adaptation of a basic scientific principle. What most astonishes me is the sheer effort they put into having a good bath. The energy, the technology, the time and the money that went into having a bath. Why was that?
Well, it's not just part of the culture, it's not just part of the social life, it's very much part of hygiene.
So it's an issue of public health as much as anything else?
Exactly.
Roman ingenuity built more than baths and aqueducts. Across the empire, engineers created the infrastructure for a way of life, a life of health and prosperity unknown elsewhere in the ancient world. Rome was everybody's role model. Whatever was served in the capital was also on the menu in the colonies. Olives from northern Africa or tropical fruits, and even rice was found in a well nearby. The Romans relied on a vibrant trade all the way to India and China. And trade sparked innovation and technological transfer. Roman trade stretched from China to the British Isles, but whether by land or water, all routes led to Rome. Rome established Ostia as its main port in the 6th century BC. Just 20 miles west of Rome on the Tiber River, Ostia became Rome's first colony. In this major supply centre, the good life meant good business. For its 50,000 inhabitants, Ostia boasted all the comforts of a Roman city, including dry cleaners and city avenues lined with multi-storey apartment buildings, as well as a sewer system and another Roman convenience, public latrines. Must have been a little crowded. In Ostia's many markets, everything changed hands, from food and everyday household goods to luxury items. Technology alone won't make you rich. For that you need organisation, and just what formidable organisers the Romans were, you can sense here. This square is known as the Piazza of the Corporations, so called because each of these niches belonged to a group of merchants who functioned exactly like a modern corporation or shipping line, specialising in particular routes and commodities from particular parts of the Roman world. This niche belonged to the merchants of Carthage, who brought wheat from North Africa. There are others for French merchants, where they bought wool, still others for Arabians bringing dates and other eastern luxuries, produce and merchants from all over the Mediterranean world. In warehouses like these, goods were marked and stored. Perishable items were placed in dolia, like these, dug into the ground to keep them cool. Simple but effective technology like this brought wealth into Roman households, into a world with an ever-growing hunger for the good life. And to meet this growing demand, the Romans began to think about scale. In the modern world, we associate the idea of mass production with the name of Henry Ford, but the Romans had a similar idea a long, long time ago. This is a flour mill, one of a dozen or so that once ground flour together in this room. The way it worked was this. The whole wheat was poured in the top, and the mill turned around through a system of rods and levers that fitted into these holes. The ground flour would then pour out from down below. This Ostia flour mill was pretty big at the time, but in the province of Gaul, the Romans made a giant leap. At Barbegal, near modern-day Arles in southern France, the Romans created one of the first prototypes of industrialization, a water-powered flour factory. Guided not over 1, but 16 water wheels in 2 parallel rows of 8, the water dropped from one wheel to the next. What made it even more efficient was, for once, a distinctly Roman invention, the overshot water wheel. It utilised water 8 times more efficiently than the traditional undershot water wheel. With this mill, the Romans could produce enough flour to feed the entire population of ancient Arles, a minimum of 12,000 people every day. Here in Ostia, large volume and lower costs meant more profits. And as the empire spread, more people enjoyed the Roman lifestyle. But the concept that increased food production propelled yet another industry. Clay drinking cups were common in ancient Rome, but the coarse clay soaked up tastes and retained odours. Absorbing oils and juices, it provided a breeding ground for bacteria. Glass, on the other hand, was odourless, tasteless and hygienic. So once glassblowing was discovered, around 50 BC in one of Rome's other colonies, modern-day Syria, the process spread across the empire in just 40 years, and a new industry was on the rise. Countless Roman glass artefacts found in the Cologne area indicate the city's past as an epicenter of glass production. Traders carried glassware from Cologne throughout the empire. It soon became another mark of refinement for the Roman lifestyle. In order to understand how the Romans met the demand, we asked a modern glassblowing company to demonstrate the Roman technique. Even today, glass is blown basically the same way the ancient Syrians did it. Put a blob of melted glass on the end of a long tube, blow air down the tube until a bubble is formed. Here is where the Romans introduced a simple but ingenious innovation. Rather than shape the bubble by hand, they used a mould. With a mould, a team of glassmakers could turn out large volume at high speed. Though moulds are now often made from metal, the Roman production concept has changed very little. "2,000 years later, the Romans still contribute to meeting the demands of the marketplace. But the Romans did more. They refined the material by inventing techniques to create some of the finest treasures of the ancient world, like this masterpiece. To this day, experts can't agree on how it was made. One researcher experimented for over 40 years. He believes he's found the answer. Through innovations like using a mould in glassmaking, the Romans raised a simple handicraft to industrialised mass production, long before Henry Ford. To understand how the Romans achieved their technological edge, researchers analyse contemporary analogues and reconstruct remnants of their culture. Still, some of their most stunning achievements remain a mystery. Like this marvel of Roman craftsmanship called caged glass. Found not in Rome but in tombs along the border, they are luxurious in their detail, but their purpose remains clouded. However, researchers believe that if they can determine how caged glass was made, they will learn more about the craftsmen and the ancient Roman civilization that supported them. I went to see a man who has spent 40 years of his life searching for the lost Roman technique. Joseph Welzel uses tools that are in essence the same as those used by the Romans. All he's added is electricity. In caged glass, a lace-like layer is supported above an inner core by small struts. There are several theories on how caged glass was created, and Herr Welzel has experimented with them all. He spends hundreds of hours creating replicas while searching for the final answer.
Do you want?
Yes, yes. Okay. This is making me extremely nervous, because if I make one mistake here, then Herr Welzel is going to be very upset with me. And secondly, makes me think of the dentist. Some of his colleagues believe that the Romans made the basic form by blowing one glass into another. Herr Welzel doesn't agree. When he replicated an earlier Roman treasure, the famous Portland vase, Herr Welzel found a clue. The Portland vase is decorated with figurine cameo cuts. Cameos were a popular Roman jewellery technique, so Herr Welzel is convinced that not glassmakers but jewellers had the skills and tools to create these treasures. In his opinion, Roman craftsmen made caged glass by cutting away from the surface of a thick-walled vessel to create the two layers. By creating replicas of Roman objects, we can learn a vast amount about the technology that went into them. The only thing hard enough to cut glass is a diamond. Now we know for a fact that the only diamonds in ancient times came from India. So to make this, the Romans had to sustain a traffic that went many thousands of miles to the east. And then there's the sheer laboriousness of the exercise. This requires many, many months of skilled labour. We learn from that the Romans used their technology not only to make their lives safer and easier, but more comfortable. This is not a necessity, it's a luxury. The whole point of this object is this: if you've got it, you flaunt it. And it went further than personal possessions. The Romans used their skills for yet another effect: intimidation. Frontier settlements like Xanten relied on it. The legions stationed here were often outnumbered by the local Germanic warriors 10 to 1. To compensate, researchers believe the Romans augmented their superior training and war machines with another strategy: psychological warfare. What made their technology such an effective tool of empire for the Romans was not just the technical difficulties it enabled them to overcome, but its political, even its psychological impact. The ability to build big, to build a building such as this one, made a massive impact on the Germanic tribes that lived in these parts. In effect, it said, we are the Romans, this is what we are capable of, and we're here to stay. The message is unequivocal. Any barbarian that takes on the Roman Empire is a very silly barbarian. Xanten's harbour temple is a clear statement. The Romans firmly believed their structures embodied the power and glory of the empire. And along with temples, arenas spoke of Roman might and engineering superiority. No colony was complete without one. But I was interested in the more practical side of the big building strategy. How'd they do it? Eventually, a replica in the park gave me the answer. The drum crane was an essential tool in the Roman build big strategy. Through an ingenious system of pulleys and winches, this remarkable machine reduced lifting force at every stage. If lifting 4,000 pounds, the first 2 pulleys with 5 rollers each divided the force needed by 1/5. The well drum divided the force again by 5. Then the winch reduced to 1/10. So 4 Romans, each using only 4 pounds of lifting power, could easily raise 4,000 pounds of whatever using this astonishing machine. Here is the ingenuity that gave the Roman architect so much muscle. With this, he could think and build big. Roman builders were also incredibly adaptable. They built what was needed with what they had. That wasn't always an easy task. Roman buildings meant solid painted walls and ceramic tile roofs. The model was Rome. On the frontier, traditional building materials were difficult to come by and expensive to import. So to meet the colonists' expectation to live in the Roman way, builders had to be creative. Architect and researcher Peter Kienzler pointed out some evidence of just how innovative the Roman builders had been at Xanten. Peter, how old is this wall?
Well, this wall's probably been built in the 2nd century AD. So what you can see here, it's the foundation, and then you get the outer surface.
Oh, so originally this wall was entirely covered with stones like this?
Exactly, you've got stones like this, row by row, and this is just the core.
Why didn't they just build the wall of stones?
Well, it's far too expensive and it takes far too long. What you do is you build up a face of stones like this, and then you pour in Roman concrete called opus cementitium behind.
Here, like in so many Roman constructions, concrete was the key. They used it everywhere for anything. Perhaps what makes it one of the Romans' greatest inventions is the adaptability of the recipe.
The first and most important ingredient is lime. This is a limestone. And the limestone is burned in a furnace, and what you get is quicklime.
This powder.
With quicklime you add water, and then you get slaked lime or lime putty. The next step is you add sand. If you mix it up, that's a basic mortar in Roman times.
Now, is this waterproof?
This is not waterproof.
In Rome, builders discovered that using pozzolanic ash from a nearby volcano made the concrete waterproof. So without volcanic ash, frontier builders had to change the recipe.
They came up with a splendid idea. Now, what you have very often is broken tiles.
Right.
So you can melt iron and use it a second time. You can melt glass, use it a second time. But you cannot reuse fired tiles. What they did was actually to grind the tiles, and you have broken tile material. This is very fine, and you add it.
You mix that in, and that does the same job as pozzolano.
Exactly. What you get is a hydraulic lime mortar, and this hydraulic lime mortar is waterproof. You use it for basins, for aqueducts, and you can use it for foundation walls.
It might not look like much, but this stuff is quite literally one of the building blocks of empire. Scale, efficiency, innovation, and, don't forget, shock and awe were at the heart of Roman Empire building. And though these ideas were manifested on an impressive level in the colonies, the city of Rome was the benchmark for everything. Little wonder that it was there that Roman technology and innovation reached their peak. Technology alone wasn't enough to build the Roman Empire. It took more. It took ideas. And while the colonies mirrored Roman ways, the standard was always set in Rome. It was there where some of the biggest ideas about scale, innovation and organisation took shape. The Colosseum is the largest of 186 Roman amphitheatres we know, and it is certainly the most impressive. It was here where technology supported a darker side of the Roman lifestyle. At the Games. The gruesome spectacles staged in this arena included slaughtering humans and animals by the thousands. Call it PR for the empire. At the Colosseum, the Romans showed off their might. It would take years of patient research to uncover the clever system the Romans used to produce their festivals of shock and awe.
We are here in the basement and we have the big puzzle from the system.
Dr. Heinz-Jürgen Bester was always fascinated by the Colosseum and its bloody history. For 8 years he researched written records and studied clues left in the ruins, trying to understand the role technology played in the horror that took place here. His search led him to the Colosseum basement and some intriguing grooves in the walls.
We have here of the right side the small corridors, and here came the animals, and we have here one place for the winch.
When he pieced together the puzzle, a startling picture emerged. The grooves supported a system of winches used to lift bears and wolves and, yes, lions and leopards onto the arena floor. Trapdoors opened that became ramps for taunted animals to charge up and join the spectacle. Their ingenuity can be found in every detail.
And we have here the original bongs for the winch.
Beautiful.
Yes, the pillars are here.
The pillar would rest in here. How did it turn around?
With the pad.
Dr. Bester explained that the base of each winch was round, and so was the bottom of the pillar. They touched only in one tangent point, making it easier to turn the pillar and lift the weight.
Off point.
So it would swing around beautifully smoothly. Yes. Brilliant, brilliant. Dr. Bester developed sophisticated graphics that reveal the secrets of the system. Like clockwork, 8 workers on 28 winches, 256 people in all, were choreographed in a system including pulleys, levers and ropes that raised 28 cages in split-second intervals, sliding their deadly freight up from the basement to join the horror taking place above.
We have here the next slide for all the wall.
I see.
For the cage.
So this is the slide up which the cage would...
Yes. We have.
So every 10 yards you'd have another... You'd have the same system over and over and over.
Yes.
And the whole thing was completely symmetrical.
Yes.
So all the way around. I've never been in a building that aroused such mixed emotions. On the one hand, this is a place of awesome, colossal beauty. And then there's the thought of what actually happened here, the blood, the cries, the fear and the pain. This basement was, if you like, the special effects department of the Roman world. The special effects for a horror movie. The difference being that here, the horror was real. Their ability to adapt simple technologies into complex systems created the foundation for the Roman way and a standard of living unparalleled in ancient times. Roman roads and bridges connected and created the Western world. The Romans leave behind a legacy of grandeur and an appreciation for bold innovations. Whether expressed through architecture, art or craftsmanship, the Romans inspire us. You can still hear the echoes and see the traces of ancient Rome. We are all, in a sense, inheritors of the Roman legacy, whether it's the necessities of our life or its luxuries. In that sense, it is fair to say that we are all a little bit Roman.